we have our notion of an infinite series, there are two questions we can ask. One is, does it converge? That is, when you add up infinitely many terms, does it add up to a finite number or not? And if it does, what does it converge to? Let's first look at convergence testing for infinite series. There are actually many ways to do this, but we're going to look at just one type of test. It's called the ratio test. So if we calculate the ratio of terms, the n plus 1th term over the nth term, so the next term in a sequence divided by the last term, and we then take the limit as n tends to infinity, so that is we skip further and further down the sequence of terms that we're adding up, and we ask, does that get smaller or larger? If this limit tends to a finite number, then the ratio test tells us the series will converge provided that number is less than 1. So the ratio test is a really neat way to find out if a series converges or not. If this number L turns out to be bigger than 1, then the series diverges. If it turns out to be equal to 1, then the test doesn't work. You have to try something else. Basically, what this test is telling us is that the terms have to get small enough, fast enough for the thing to converge. Let's see this in action with a few examples. So let's have a look at this for x to the n, summed from n equals 0 to infinity. We already saw how to work this out directly, but let's use the ratio test on this to see what happens. So the ratio test takes us to take the n plus 1th term, which is x to the n plus 1 divided by the nth term, and this is just equal to mod x. And so the ratio test tells us that this series converges provided mod x is less than 1. So what's happened there in the ratio doesn't depend on n, so as n tends to infinity we're just left with mod x, and if mod x is less than 1 the series converges. Let's take a series that we're going to see actually come up quite a lot. I won't say what it is just yet, but does this series converge? So let's have a go at the ratio test. So take the limit, and we'll take the n plus 1th term, so that's x to the n plus 1 over n plus 1 factorial, and divide it by the nth term. Okay, so a bit of a big mess to work out, but let's go through it. Let's separate out the bits with x's and then the bits with factorials. Now, we simplify. The bit with x's just becomes mod x, and the bit with factorials we can simplify if we write n plus 1 factorial as n plus 1 times n factorial. The n factorials cancel, so this is equal to, and as n tends to infinity, that just tends to 0, so therefore the series converges. And it converges for all numbers x, it doesn't matter what number you choose in there. So that series then converges for all x, but we don't know what it converges to yet. So in fact, the values of x for which those series converge, in the first example we converge for x mod x less than 1, and in the second one it didn't matter what x was. In which case we say that the first series has a radius of convergence of 1, and the second case the radius of convergence is infinity. Let's try an example of what's called a Bessel function. Now a Bessel function is a type of function which doesn't have a definition in terms of elementary functions, but it does have a definition in terms of infinite series. One of these Bessel functions is the so-called Bessel function of order 0, which is given by, so quite an untidy looking thing, and it's an example of a function defined through a power series. Does it converge? Let's have a go. We don't need to worry about the minus 1 to the n, and we divide by the nth term, and this simplifies down to, so using exactly the same trick for the factorials we did before, that simplifies to x squared over 4 times 1 over n plus 1 squared, and that tends to 0 as n tends to infinity. And so the radius of convergence of the Bessel series is equal to infinity. And as we see, the Bessel function is an oscillating function, but the period changes as you move along the x-axis. In general, a power series might be not centered at x equals 0, it could be centered at some number x equals a. This has a general representation of the sum of terms of Cn, where Cn's are just a constant that depend on n, they depend how far down the series you are, times x minus a to the n. This has a radius of convergence r, which means that if x minus a, mod x minus a less than r, then the series converges. And if mod x minus a is greater than r, it diverges.